Hope you're not too tired because this one is a cracker. This one is an analysis problem as opposed to the design problems that we were doing before. You are to analyze the given circuit and determine the voltages at all nodes and the currents through all branches. Now let me write the MOSFET data. Now let me write the circuit data available to us. So let's get straight into this. First of all, notice that the current at the gate is 0 by definition. The voltage at the gate can be found by employing a simple voltage divider formed by the two 10 mega ohm resistors. This comes out to be 5 volts. So we write it here. With this positive voltage at the gate, the NMOS transistor will be turned on. However, we do not know which mode the transistor will be operating in. Namely, will it be in triode or in saturation? Now what we have to do is that we can assume one of the two situations and we can say that the NMOS is assumed to be in saturation. Then we make the calculations and verify our assumption at the end. If the NMOS is indeed proven to be in saturation, then our calculated values are accurate. If the NMOS is proven to be in triode, then our calculated values are wrong. So, now refer back to the figure. The voltage at the source is 6ID. Do you agree? Now VGS will be equal to 5 minus 6ID. ID is also given by the standard equation for the current in the saturation region. You plug in the values and you get this expression. Notice that this sign here, the milli, is removed if you consider ID to be in milliamperes. So this simplifies our expression and we can simply write multiplied by 1. Now as you can see that this is going to result in another quadratic equation. So we are going to write that. Solving this, we are going to get two values. ID equals 0.89 milliamperes and 0.5 milliamperes. The first value results in a source voltage of 5.34 volts. However, this is greater than the gate voltage of 5 volts and this will imply that the NMOS transistor is cut off, which is not the case. So we reject this value. Using the other value, 0.5 milliampere, we make the rest of our calculations. And we get the value of Vs as 3 volts, VGS comes out to be 2 volts and VD is 7 volts. Pretty simple, yeah? Now we check our assumption. For the transistor to be in saturation, this condition has to be satisfied. So we plug in the values and we see that indeed the transistor is in saturation. So our assumption is correct. The current through the voltage divider is easy to find. It is 0.5 microamperes.